Here we're going to look at question 10 from section 2 of the ENGAA specimen paper. So in this question we're told that we have a heavy rock which is attached with 4 cables and they pull the rock at a velocity of 0.2 meters per second. So we're told the cross-sectional area of each of the cables is 2 centimeters squared. They each undergo an elastic strain of 0.0025 and they have a Young's modulus of 2 times 10 to the 11 pascals. So with this information, the question asks us, what is the power transferred by the cables? If you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it. So to think about this question, let's try and see if we have a bit of a think about where power might come into it. So what equations do we know for power? Well, one of them is that we know that power is equal to the force of an object multiplied by the velocity the object is moving at. So here, the power being transferred through one of the cables is going to be the force the cable produces multiplied by the velocity. So in this case though, the total power produced by the cables is just going to be 4 multiplied by this, since we have 4 different cables. Now this is actually quite handy because we have the velocity, we know the rock is moving at 0.2 meters per second, but unfortunately we do not know the force that the cables are pulling with. So let's see if we can have a bit of a think about our other information, see if that will lead us towards the force being produced by the cables. So we've been given a Young's modulus. Now let's have a bit of a think about what a Young's modulus actually is. It's generally a topic which people tend to hate, but basically Young's modulus is just the stress that a wire is undergoing divided by the elastic strain. So we were told the elastic strain before, but we don't know what stress is, so let's have a bit of a think. There is an equation for stress, and it is that the force being the wire's kind of undergoing, or it's the force that our wire is undergoing divided by the cross-sectional area of our wire. So this looks really good now because actually we have a force in here, and we know the elastic strain, we know the Young's modulus, and actually we've just been told, well, we know the area as well, the cross-sectional area, sorry. So mixing these two equations together, we get this with our 3 variables that we know, with our force that we don't. So of course we can just rearrange this to get our force. And now with this we can substitute it back into our equation at the top here to get an expression of power which is given here. So next, the thing to do is to simply substitute in the different variables we've been given. So doing so gives you this right here with our velocity of 2 times 10 to minus 1 meters per second, which was labelled on the diagram at the top. So all you have to do now is work through and multiply these, which is a bit tricky since there's a few different numbers, but it shouldn't take too long. And you simply come out with an answer of 8 times 10 to the 4 watts. So this is just going to correspond with answer C given in the question.